Okay, now let's look at the definition of progressive waves. So progressive waves are waves whose wave profiles move and energy is transmitted from one point to another. So what does it mean by wave profiles move? So you imagine, right, when you are near the seaside and when you watch the water waves, you will see them moving towards you, right now. So let's say you are at the seaside, you'll see the water waves move towards you. So the shape of the wave here is called the wave profile. So you see this shape moving towards you, all right? And energy is transmitted from one point to another, because if the waves actually hit you, you will feel some energy in it. It will push you away. Right, so there are two types of progressive waves, which we will talk about in the next part. But basically, in a progressive waves, the particles only oscillate, but the waves travel. So what do I mean by that? Let's look at the next example. If you go to the stadium and watch the people do a Mexican wave, all right, so let's take a section of the stadium, for example, this way. Right, you will notice that to start the Mexican wave, the first person has to start standing up and sitting down, and after he starts for a little while, then the second person must follow him, then the third person will follow him. All right, so what will happen is you'll realize that for the waves to continuously travel, the person here will just take turns to move up and down, followed by this person, followed by this person. So they actually take turns, and by taking turns, you'll see the wave traveling across the stadium. So very important to realize is that in a transverse wave, for example, so this is a transverse wave, the particles will actually oscillate up and down as the travels move from left to right. So that's why we will see that for this type of transverse waves, the direction of oscillation of particles is actually perpendicular to wave travel. In a longitudinal wave, right, for example, okay, let's look at another example. Let's say you are at a concert and you're watching the artist singing, right? So there are many people in the audience. So let's say the first person, he starts to sway, all right? So let's say the first person starts to sway left to right. So what will happen is the person next to him will follow. So he will also sway from left to right, and then the next person will start to sway left to right. So again, what will the particles do? They will only oscillate about a fixed point. But as they oscillate about a fixed point and take turns, right, you will see the wave traveling across the hall, for example. So what you will see is the direction of oscillation of particles, all right, is actually parallel to direction of travel. So this is what you call as a longitudinal wave. But once again, whether it's a transverse or longitudinal wave, particles oscillate but waves travel.